Welcome to Mimi's Math Channel. This video will discuss how to solve trig equations. Make sure you have access to the unit circle. Also make note of signs in each quadrant, as well as the tangent values. So this is what I mean. You're going to want to memorize the tangent values. It's easy once you look at your quadrant 1 to memorize the cosine and the sine because they represent, cosine represents your x and sine represents your y. Tangent, however, is y over x. So you're going to actually have to do some calculations, which I showed you in another video. In example 1, what you want to do is you want to isolate the trig function sine. And the way that we're going to do that initially is we're going to add 5 on both sides. It's just like you're doing algebra problem. So we're going to go ahead and simplify that, and that's going to be 1 is equal to -2 sine theta. Now we do have constraints. Our constraints are that our answers are going to be between 0 and 2 pi radians. So we're not trying to find all solutions in this case. So make sure you look for instructions that tell you not only your constraints, but should your answer be in radians or should it be in degrees? So I'm going to do both. So in degrees, it would look like this. Another way that you would see it is in interval notation, where you would see a bracket 0, comma, 2 pi radians, parentheses. So both of those mean the same thing. This means the same thing. All right, let's continue on with the problem, working this through. All right, now I see that sine is not by itself. What I need to do is divide both sides by -2. And that gives me that sine theta is -1/2. I said earlier that sine represents your y values. So the way that I remember it is I look at where my y values are negative. And I see that in quadrants 3 and 4, I'm going to have negative y values. And then I'll just look for -1/2. So over here, I see it right here, -1/2. And that's going to give me 7 pi radians 6. And then if I go over here, which is reflected, I still see that -1/2 as a y, and it's 11 pi radians over 6. And I'm writing it as radians because that's what my instructions asked me to do, to find my solutions that are between 0 and 2 pi radians. On the other side, if it asked me to find the solution where it's between 0 and 360, I'm going to go back to my unit circle where it's 7 pi radians and over 6 and 11 pi radians over 6, and I'm going to find the degree for that. So I have 210 and I have 330 degrees. All right, moving on to example 2. So for example 2, what we're going to try to do before we try to solve this is look at the radical in terms of if it were an x. So if you had something like 4 minus 3x set equal to -5x, if I asked you to combine your x's, what would you do? You would add 3x to both sides, right? So that's what we're going to do with our radical. We're going to go ahead and we're going to, in this case, since it's a -3√2, we're going to add 3√2 to both sides. And then we're going to bring down what's left over, which is 4 cosine of theta is equal to, now over back to where the x's are. We do nothing with that x except bring it down, and then we just simplify what's in front of it, which is going to be -2, right? Well, we're going to do the same thing over here with our √2. So -5 plus 3 is -2, and then you just bring down the √2. At this point, what I want to do is to get my cosine by itself, cosine theta, so I'm going to divide both sides by this 4, so I can get rid of that. And so cosine theta is going to equal to, I can simplify the numbers on the outside, so I have -√2 over 2. So it's really -1/2, but it's understood that there's a 1 in front of that √2. So I know that cosine is really my x values, and what I want to do is look at my quadrants and determine where are the x values negative. So I know that's going to be in quadrant 2 and quadrant 3. So when I go back up to my unit circle, I'm looking for this answer here. Where is cosine, or x, -√2 over 2 in quadrants 2 and 3? So in quadrants 2, I see that it's at 3 pi radians over 4. And also if I look in quadrant 3, which is down here, it's going to be at 5 pi radians 4. Now if I wanted to see what it's like as a degree, then I would go back to where it's 3 pi radians over 4 and 5 pi radians over 4. And I see that 3 pi radians over 4 is 135 and 5 pi radians over 4 is 225. On to example 3. So I'm asked to solve this equation. This time I have tangent, and so that's the one that's y over x. So we're gonna probably do a couple more steps here. What I would do, since I have a fraction over here with a radical, is I would separate everything. So I'm gonna have 3 over 3 minus root 3 over 3, and then I'm gonna be moving this 1 over. Well, the 1 as a fraction is negative 3 over 3. So now I'm going to go ahead and simplify this. I now have tangent on the side by itself. I just need to simplify the left-hand side. Well, I have a positive 3 over 3 and a negative 3 over 3, which results in 0. So my tangent theta is negative root 3 over 3. Now I know, again, that this is y over x. And what I would do is refer to those notes on the side and pay attention to where it's root 3 over 3. However, this one says negative. So I know my reference angle is 30. So I know anything that's attached to 30, if I look at the reflection portion of it, it's going to have something to do with this root 3 over 3. Or better yet, look for your denominator where it's 6, and that's even better. So where would it be negative? If I had, it's either one or the other is negative. I can't have both negative. If both are negative, this is going to turn into a positive answer if I have y over x, and then both of these are already positive. So my only choices would be quadrants 2 and 4. And so therefore I know my theta is going to be 5 pi radians over 6 and 11 pi radians over 6. If I go to where it's 5 pi radians over 6, I see that my degree measures 150 if I'm trying to use this interval now. And if I go across from it, I see that 11 pi radians is equivalent to 330 degrees. So that's my answer here. The last example is example 4, where we're going to solve this equation. And you notice you have a square this time. So what I'm going to do is show you what you would do if you had an x. Instead of 2 sine squared, we're going to say 2x squared minus 3x plus 1 is equal to 0. And this one, I'm going to just do a guess and check to go quickly. So we know 2x times x is going to give us the 2x squared. And now we need to find something that's going to give us 1, and that's simply 1 times 1. And then you want to take what's on the inside, 1x, and you want to take what's on the outside, 2x times 1. You want to determine what would the signs be in order to get this negative 3x. Well, if I put a negative and a negative here, in the middle, negative 1 times x is negative 1x. And then on the outsides, 2x times negative 1 is negative 2x. And so if I combine that, that is negative 3x. So I know that I factored this correctly. So I'm going to take this same idea, but instead of using x, I'm going to use sine. So I would have 2 times sine theta minus 1 times sine theta minus 1. Now I'm setting this equal to 0 because that's what my original equation looks like. And now I can use my zero product property, set each one of these factors equal to 0 and solve. So in order to solve, I'm going to add 1 to both sides, and then I'm going to divide both sides by 2. So on this side, sine theta is equal to 1 over 2. And I know that this is my y value on my unit circle. And I have 2 places where sine is equal to 1/2. So I'm going to start my set interval because I still have another, I have to do this side as well. So for 1/2, if I look at my unit circle over here, where y is 1/2, so I see in quadrant 1 and quadrant 2, my y value is positive 1/2 will be right here, as well as right here. So they're connected. 30 degrees is my reference angle. And so therefore my answer over here will be pi radians over 6, which is my 30 degrees, and then 5 pi radians over 6, which is my 150 degrees. Now, on this side, all I have to do is add 1 to both sides of the equation, and therefore I'm looking for where sine theta is equal to 1. Well, the only place that is equal to 1, if I just think about my coordinates, is 0, 1. And this is going to be my 90 degree, or pi radians over 2 answer. All right, so pi radians over 2 goes here. So that's my set in terms of radians if I'm following this interval. But if I'm over here, is what I mentioned before. It's going to be the set of 30 degrees 90 degrees, and 150. So if I wanted to check my work, which I would recommend that you do, then you want to go back to your original problem, which was 2, this sine squared, minus 3 times sine theta plus 1 equals 0. So when you substitute those values in, you really have 2 times, and you're looking for where sine of pi radians over 6 is located. And we said that it's 30 degrees. However, what is that? That's going to be 1/2. And it's the same if it were 150 degrees. It's still 1/2. It's the same if it's pi radian over 6 or 5 pi radians over 6. It still equals this 1/2. So that's what I'm going to be replacing all of this with, all of the sine thetas. So I'm going to replace this with 1/2. However, it's squared, minus 3 times 1/2 plus 1. And now I have 2 times 1 over 4 minus 3/2 plus 1. Once I simplify this, this is 1/2 minus 3/2, and then this 1 takes the denominator, and I'm just going to add it over itself. So 2 over 2, that's still equivalent to 1, is equal to 0. And now simplifying, I have 1 minus 3, which is negative 2 over 2, plus 2 over 2. And as you can see, that's going to cancel out, which leaves me with 0 is in fact equal to 0. So I know that that solution worked. I would do the same thing for this one. Well, we know that that's 90 degrees, which is on the y-axis as 1. So I would just substitute in 1 squared minus 3 times 1 plus 1 is equal to 0. And once I simplify this, this is simply 2 minus 3 plus 1 is equal to 0. Simplifying this, 2 minus 3 is negative 1 plus 1 equals 0. I know that this one works as well because 0 does in fact equal 0. Please remember to like and subscribe. Have an awesome day.
Subscribe.